This is 5.1, the unit circle. I did make a video about how to create the unit circle and how to like literally label every part of the unit circle. You may want to watch that first to make sure that you're familiar with the unit circle. All right, so again, here's the formula for the circle. If you remember the basic idea, x minus h squared plus y minus k squared equals r squared. Well, the unit circle, since we know it's centered at 0, 0, and the radius is 1, that's why we're going from here to there. So this is, again, the unit circle, the formula that we're going to be using. So here's a good example. So if I want to show that this point P, this coordinate, is on the unit circle. So again, if I put that in decimal, you can actually make a decimal out of that and a decimal out of that, and that's a point you would graph, and I want to see if it's on the unit circle. So one way to do it is we can just simply follow this x squared plus y squared and see if it equals 1. So if we take the x coordinate and we take the y coordinate and we square them, we simplify that, and we can see it does equal 1. So this point is on the unit circle. Let's look at another point, point square root of 3 over 2. And notice I don't give you the y, but I'm telling you it's on the unit circle, and I'm also telling you it's in quadrant 4. So if we follow that unit circle, x squared plus y squared equals 1, the equation of the unit circle, and we plug in what we do know, which is the x, and we plug that in, we solve for y, we notice we get y is positive 1/2 or negative 1/2. Well, which one is it? Well, if we look, it's got to be quadrant 4, right? They tell us in quadrant 4. Well, think of all the points in quadrant 4. Every one of those points, like let's just say this one, I'm just going to make this number up. So this might be like 2, -7 or something like that. And then this might be 1, -9. Or, notice everything in this quadrant 4, the y part of it is a negative number. So because it's in the quadrant 4, y has to be a negative number. So the coordinate of this point is square root of 3 over 2 and then negative 1/2. That is my x and that is my y. So let's talk about terminal points. So terminal points are points on the unit circle. So keep in mind the unit circle. Everything we're talking about is on the unit circle. So it's traveling counterclockwise for positive t distance. And of course, we could also do negative t distance traveling actual clockwise. So here's an example. Here I have the terminal point. I already have it highlighted and stuff, but basically you're going to start at this 0, 0. Or 1, 0, 0, 0 is right here, but 1, 0, and then you're going to go counterclockwise all the way to this point. And so this is a terminal. Think of the word terminal means ending. So the ending point, that's what a terminal point is. And some common examples that we're going to be talking about, if t is pi over 2, and of course we remember the radian, the unit circle, so pi over 2 is basically 90 degrees. So if this was going from here to here, this would be pi over 2. That's the terminal point. Or all the way to pi, 3 pi over 2, and then all the way around the circle, 2 pi. So again, the terminal point is the ending point on the unit circle. All right, so the reference number, we need to talk about the reference number. You should have learned this in geometry and in Algebra 2 class. So we're going to denote it with t bar over it. It's the shortest distance along the unit circle to the x-axis. So again, if I have t equals 7 pi over 6. So again, I'm traveling from here to here. I go 7 pi over 6. So that, again, one way to look at this is, you're going pi is half a circle, and then you're going 1/6 more. And that's what you're kind of doing. So the reference number is pi over 6 because it's literally the shortest distance past all the way to the x-axis, the shortest distance to the x-axis. So that's what you need to find. So the reference number in this illustration, so t equals 7 force pi, so I go 7 force pi. So again, I always go counterclockwise. I'm moving around the circle. I get to 7 force pi. And then notice what's left over is 1/4 pi. Again, I can simply just get that by 2 pi minus 7 fourths pi. Take the shortest distance, what remains left to go all the way around the circle, all the way to the x-axis. Not the y-axis, but the x-axis. And that's going to come in handy when we find the terminal point. So when we're going to find the terminal point of each of these, so look at letter A. If I ask you to find if t equals negative pi over 4. So if I go negative pi over 4, so I'm moving in the clockwise direction, so negative pi over 4. So there's a couple ways we could do this. So one way we could do it, back when on the unit circle, just as a reminder, I specifically emphasized these 3 points. So you have 1, 0, and you have 0, 1. But these 3 points are going to be key knowing these 3 points. So this is the 45-degree angle, and so this is actually going to be square root of 2 over 2. That's the x coordinate and the y coordinate. This next one is a 30-degree, okay, 30-degree angle, but it's also so the coordinate would be square root of 3 over 2, 1/2. And this last one, 30, 45, and 60. Those are the 3 that you need to pay attention to. 30-degree angle, 45, and then a 60-degree angle. So this would be 1/2 square root of 3 over 2. So the reason why that's going to help us, because that's in quadrant 1. So keep in mind also, when you have first quadrant, second quadrant, and third quadrant, fourth quadrant, each quadrant has, like everything in quadrant 1, the x and the y part, the x and the y, they're both going to be positive. This is going to be positive, this is going to be positive. Over here, everything's going to be negative for the x's, but positive for the y's. Over here, both the x's are going to be negative, the x's are going to be negative, and the y's are going to be negative. And over here, the x's are positive, and the y's are negative. Okay, so just keep that in mind when you're graphing this. So all the way around, so what we're trying to find is a negative pi over 4. So this is actually the reference of this. We're trying to find the terminal point, but the reference point is literally pi over 4. Or if you think of it, if you want to convert that to degrees, so you're thinking that way. So this is a 45-degree angle is what we're considering, a pi over 4 or 45 degrees. So that's the same thing as this pink, square root of 2 over 2, square root of 2 over 2, but notice it's in the fourth quadrant. So this right here will literally have the terminal point of this would be square root of 2 over 2 positive, and then negative square root of 2 over 2. Again, it's a 45-degree angle, so which we're talking about, that little pink one that I have written up there, but it's in the fourth quadrant, so which means it's going to be positive and then negative. So let's look at this one right here. The second one, part B. Part B, again, we have 3/4 pi, but again, if you look at the reference number, the reference number is like the distance left over to the x-axis. Let me back that up and draw a circle here. So this is 1/4 pi, the reference number is, which is again a 45-degree angle, pi over 4, but it's in the second quadrant. So in the second quadrant, so this would be negative square root of 2 over 2, and then square root of 2 over 2. Again, the second quadrant is negative for the x's and then positive for the y's. And again, negative 5 pi over 6. So again, the reference number is pi over 6, which if you want to convert that to degrees, that means it's a 30-degree angle, which means we're going to use the black angle here, square root of 3 over 2, 1/2. And notice it's also in the third quadrant, which means both things are negative. So this has the reference point both things are negative, so it's going to be negative square root of 3 over 2, and then negative 1/2. So 3, negative square root of 3. All right, so that's how you would find the terminal points, and using the unit circle and also the quadrants, which ones are the signs of it. The signs of each ones are the quadrants. I also, just a quick comment, wanted to point out to you that I'm looking for exact answers for the terminal point, not decimal approximations. And the reason is because, a decimal approximation, we could simply, we could also be doing this using a calculator and simply doing, remember, a point is made up of cosine, sine. And so we literally could just take the cosine, we could literally just do the cosine of negative 5 pi over 6 and the sine of negative 5 pi over 6. And it would give me my answer in decimal approximations. Well, the negative 1/2, it would come out nice. But, and by the way, I just want to mention that's in radian mode. You'd have to do the cosine and sine in radian mode. But again, I'm looking for the exact answers. Just wanted to make that clarification, not the decimal approximations, because I want to emphasize to you knowing the unit circle.